Hello everyone, my name is Harshit and this is my presentation for my Capstone project for the course for Advanced Data Science offered by IBM. So the title of my project is Forest Fire Prediction Model based on Neural Network Approach. So first of all, we'll be getting into the use case for this project. So in recent years, we have seen that a lot of major forest fire disasters have happened all across the world, and organizations globally are trying harder to predict and mitigate the losses from these fires. And these are some of the organizations which are involved in this work. And the biggest names are UNEP, United States Forest Service. And what we do try to do while predicting such uh, naturally occurring uh, phenomena is that we try to relate features like meteorological data and geographical data and try to see if there is any connection or we can predict on the basis of them. So a similar attempt has been made in my project as well. So coming on to the Jupyter notebook. So this is our Jupyter notebook, and firstly we will start by importing our libraries, which are pandas, numpy, scikit-learn, and keras. And we'll be using TensorFlow backend. So let's just go ahead and read our CSV file. So here's how we do it: amazon.csv, and this is our data frame. So these are our features. These are our features, and this is our label. So fire is our label, and it's a binary label: 0 for no occurrences reported, and 1 for fire occurrence reported. Yes. So this will be in 0 and 1 only, and this is actually a bogus column because it is containing only serial values, like right over here. And these are our features. So we'll go ahead and describe our data frame, which shows us a lot of statistics about various columns. And for precipitation, what we see is our mean is 0.88, but maximum is 34.5, which indicates that there might be a lot of outliers in this column. But actually, okay, we'll first see how things are going on in this column. So we'll visualize it by using matplotlib histogram plot. So yeah, a lot of values are in between 0 to 3, 4, 5 centimeters of rainfall uh, for our precipitation, but there are very few values ahead, and there is only actually the maximum value is 34.5, which is possibly only the single value present in that bin. So instead of treating it as outlier and try to pluck it out, we will use a different technique called bucketization, in which what we will do is we will create a range and replace our values, our entries with weights that we want our model to use, which is done over here. So like from 15 to 45 in this range, if any value is falling, it will be replaced by 3. And so what this does is this lets basically our model know that it's the difference might not be between 0 to 0.1 to 0.2 centimeter of rainfall, because that is not physically significant, and also these values are coming from observatories which are in operating in one location, and we might be studying a bigger area of interest. So these are a few reasons why we don't treat them as outliers. Instead, we give them weights, and in my experience, this has worked very well for us. And yeah, so we have taken out the precipitation, the bucketized precipitation, and now we are left with this our data frame. So we'll remove this column and precipitation column, uh, so which is done over here. And now we'll extract features and labels differently. And see, the thing is, we have a lot of values between 1000 and so. but here we have like 30, 11. So the scales are all arbitrary, so we'll plug them into a scalar. So I have used min max scalar over here. So we'll plug our label and our features into this, and then we'll append or concatenate our bucketized precipitation with the rest of the features. And this is our what our final feature looks like. So we'll plug this in our model. So we'll be using, since we are using neural network approach, we'll be using sequential. We'll be making the architecture using dense, defining the number of layers and the number of nodes in each layer, and the activation function in them. So we have the number of features that we have is 5, so the input dimension will be 5, and the metric has been set as accuracy, and loss is mean square error. So when we train this model, I get an accuracy of about 76%, and we can actually see how the model is performing by plotting two graphs, which is accuracy versus epoch and loss versus epoch. So we see that accuracy is increasing as the for training and validation datasets, both of them, and which is a good thing. And loss is continuously decreasing, and we don't see any signs of overfitting because the graph does not go like this. So this might mean that there is a very low chance that we'll be getting a problem of overfitting in this problem due to the nature of the problem. And then we can just tweak around the values for our model, different values for epoch, size, batch size, and layers, and number of nodes in each layer, and almost all, there won't be a lot of change in accuracy. So like these set of hyperparameters are giving 75.27%, but the performance of what we can see in the graph is almost similar. So this almost concludes that there will not be any chance of overfitting because losses, there are spikes, but overall loss is not actually coming up by a significant percentage. So yeah, the best accuracy that I have gotten until now is 76.10, which was after I bucketized the precipitation curve. So this will be all. Thank you all everyone. I hope you enjoy your day. Goodbye.